Welcome to the Shanti-Peace for mathematics. So this video I am preparing due to one of the comments on my another video exponential power of a complex number. So in that Mr. Nisarg has asked me a question, what will be the proof of Euler's formula. So the Euler's formula is stated as e raised to I theta is equal to cos theta plus I sin theta for any theta belongs to R. That means theta is the any real number that you have. So this Euler's formula is a beautiful construction of complex analysis because it's involved the exponential function. It gives the relation between the exponential function, cos, that is trigonometric functions, and sine functions. So I am giving you a two proof in this video for the Euler's formula. So for that, the first proof, I am defining a function f which is from R to C as f of t is equal to e raised to minus it cos t plus I sin t for any t belongs to R. Now you can check that this function is continuous and differentiable, and if it is differentiable we can talk about its derivative. So f dash of t if I take, then using the product rule we can write as e raised to minus it is as it is, and the derivative of cos t is minus sin t plus I cos t. So the derivative of this quantity will gives you this one plus e raised to minus it into the derivative of minus it will be minus I with respect to t into cos t plus I sin t is as it is. Now if I can common out the e raised to minus it from it, it will gives you minus sin t plus I cos t. Now this minus I will multiply to cos t here, so it will be minus I cos t, and this I is also multiplied to this I, so that will be I square, and this so I square will become minus 1 and this minus will become plus sin t. So we can observe that this minus sin t will cancel with this plus sin t, and I cos t will cancel with this. So that's the 0 for any t belongs to R. So that's why this will gives you f dash of t is 0 for any t belongs to R, and so therefore we can say that f is a constant function. But you may observe what is f of 0. So in this if you can put x t equal to 0 here, then it is e raised to 0 cos 0 plus I sin 0 will have, so it will be e raised to 0 into cos 0 plus I sin 0, and you know that cos 0 will be 1, sin 0 is 0, and e raised to 0 is 1, so the answer is 1. Since f is constant function and at 0 it has the value 1, so that means we can say that f of t will be 1 for every t belongs to R. So that gives you e raised to minus t cos t plus I sin t will be 1. So therefore it is, here it is I. So therefore it is e raised to it will be cos t plus I sin t. So that completes the proof for Euler's formula. And the another proof of I am giving you by a series solution. So for that actually you required a lots of use of extension of the results that you have in a real analysis. So you probably know that e raised to x, the Maclaurin expansion or a Taylor series expansion about 0 of e power x is 1 plus x square by 2 factorial x cube by 3 factorial and so on. And for x belongs to R, this is true. Similarly, if x is a complex number, that means e power z is there, then also if your z is a complex number, then also we can have the same Taylor series expansion for that about 0. If I put z is equal to e raised to I theta, then this expansion will gives you I theta plus I theta square upon 2 factorial I theta power cube upon 3 factorial and so on. And if I use the I theta is as it is, and I square, if I have the powers, so now the powers of I square will become minus 1, so this will become minus theta square upon 2 factorial, I cube become minus I, so this will be minus I theta cube upon 3 factorial. The next term will be I raised to I theta raised to 4 upon 4 factorial. So I power 4, you will have it is 1. So it is plus theta raised to 4 upon 4 factorial. The next one is I theta power 5 upon 5 factorial. Then I raised to 5 will be I. So that is plus I theta power 5 upon 5 factorial and so on. So if you can see this, and if you common out the real parts, that is the terms without I, so if you can common out all the terms in this series, so that will gives you 1 minus theta power square 2 factorial plus theta power 4 upon 4 factorial and so on, plus I. The coefficients of I will be theta minus theta cube upon 3 factorial plus theta raised to 5 upon 5 factorial and so on. And you can observe that this is the nothing but the Maclaurin series for cos theta plus I, and this will be the Maclaurin series for sin theta. Thank you very much for listening me, and if you have any doubt, please comment on the comment box. Thank you very much. Bye bye. Sayonara.